Okay, so we're back now. I've cleaned this up a little bit to have less distractions, fewer distractions on the sheet here. We're now in part 3. We're now going to connect some of this information from the table of values and the equation to the graph. So last time we looked at first differences, and we noticed that for every different row, there's a difference of $100 in the total cost of the banquet. Here, and that corresponds to a change of 5 guests per row. We looked at the total cost, the change in total cost, which comes from the first differences, so we know that's $100, and that corresponds with the change in guests, which is 5, and which then tells us that the rate of change is actually $10 per guest, sorry, $20 per guest, which is the same as the cost per plate. Okay, so we looked at all that. Now, the reason why we're using the word first differences is because in subsequent years, we will look at that, and then we will go on and we will then look at second differences. And second differences will subtract the first differences. And if we do 100 minus 100, we get 0. 100 minus 100 is 0. 100 minus 100 is 0. So notice, of course, that when the differences are constant, and that's the important thing to think of, when the differences are constant, then that means that the second differences are going to be 0, okay, which makes sense because we're just subtracting the same numbers. Okay, we matched the $20 per plate with the rate of change of total cost to the coefficient of the variable term. And of course, then we also have the constant term of 250, which is just the constant in the equation. Now, when we go back, and I know I graphed this before, and I didn't put these ordered pairs in here, which I'll do again though. So this ordered pair is 0 and 250. That first point. The second point is 5 and 350. The third point is 10 and 450. Then we've got 15 and 550. Okay, so I'll just stop there. So those are all the ordered pairs of the points. We notice, of course, that the constant, 250, which is the reservation fee, we notice that that corresponds to this first point, or this first point is plotted because of the values of the independent and the dependent variable being 0 and 250. Okay, so that's the ordered pair, and that is the first point. Then we've got the second point, 5 guests and 350, and so that is right here. So 5 and 350 matches up with this point. And I'll just highlight one more. 10 and 450 gives us this point here. Okay, so how does all this link together? Well, we know that the table of values dictates where these points are plotted on the grid. The points form this relationship. And as you can see, a line, and in math, when we talk about a line, mathematically, if you say the word line, it's always understood to be straight. Okay, so there's no real need, now it's not wrong if you do, but there's no real need to say straight line. Because if you're talking to a math person, line is straight. And if it's not straight, then, so if it's not straight, it's called a curve. Okay, so a line in math is always straight, and a curve is not straight. A line, actually, that's the root word of part of what this this topic we're discussing. We're talking about linear relations. So line is the root of linear, and so we're talking about linear relation. We notice that that's a straight line, or it's a line, and so therefore this relation is linear. So the relation between total cost and the number of guests is linear. If it's not straight, so i.e. if it's a curve, we would then say that that's non-linear. We don't have to describe it with any more specific terms at this moment. We can just say it's non-linear. So we have a linear relation, which is between total cost and the number of guests. We know that we look at this and we see that it's a line. And we notice that when we go back up to the table of values, the difference in total cost from one row to the next is 100, when the difference between one row to the next in number of guests is 5. Okay, so that's constant all the way along. So if I were to, and I'm not sure how useful this is going to be, or how accurate this is going to be. If I draw a line, or if I draw a line from, yeah, I didn't get it. Okay. See if I can drag that at all. I can't seem to grab that. I don't know. Anyways, so this line, I'll try it again. This line goes from 350. Oh, now I got it right on. That's horrible. Okay, let's try that again. Sorry. As you see me making feeble attempts here. Okay. So we're going from 350, the total cost 350, all the way along to the y-axis. I'm just going to draw this freehand. That's supposed to be straight. And then if I go from this point up to where this line hits the y-axis, notice that I'm forming a triangle. And this triangle is a right triangle. And we've got, if you recall from right triangles in Pythagorean theorem, that we've got these two legs of the triangle, and those two legs are vertical and horizontal. They match, they are parallel to the two axes. And then we've got the hypotenuse of the triangle. Okay. And so if I take a close look at this, I would notice that this horizontal leg of the right triangle is as long as from 0 to 5 on the x-axis, the dependent or the independent axis, which is the number of guests. So this corresponds to a length of 5. This is actually the change in n, which we see up in the table of values. Okay, so each of these changes in n is 5. So that's the change in n here. And over this vertical leg here goes from 250 up to 350. So that change, that vertical leg, that's a change of 100. I'll just put this 100 right here. Okay, and that's the change in cost. Okay, that vertical part here is the change in cost, which is 100. So notice how this vertical change for this triangle is the same as the change, the first difference in the table of values. And that's actually the change in cost. And that actually, if we were to expand this out to a larger triangle, what if we were to jump 2 spaces? So let's or like 2 rows in the table of values. If I start up here at 15 and 550, if I come along here, along 550, and stop, it's supposed to be up here, and if I stop right above this point, so this point has that vertical leg. So I'm drawing the 2 legs again, the horizontal and the vertical leg. Notice that the horizontal leg of this right triangle starts at 5. So that's an independent value of 5, and it goes to an independent value of 15. Well, that change in number of guests is 10. And here we see this vertical value, this dependent value is 550. And where we left this off, down at 0.5 and 350, this cost is 350. So this is a change. This change in cost is 200. Well, what happens if I were to take this 100 here, the change in cost, the vertical, and divide by the change in number of guests? Well, that's 100 divided by 5, which is 20, just like we had when we did the rate of change calculation from the table of values. And if I were to do this again up for this other triangle, which is larger than the first triangle, again, change in cost over change in number of guests. And what I'm calculating here is the rate of change of total cost. We see that the change in cost in this triangle, in this larger triangle, is 200, where the change in number of guests is 10. And if I divide that, I get 20. So notice that the rate of change is 20, whether I use a small triangle or a larger triangle. And notice that the increase, if we look at the line itself, the line obviously is straight. It's a constant increase as we go along here. So for every 5 guests, or for that matter, even every 1 guest, because each rate of change, as we simplify it, is per 1 guest. So $20 per guest. In both of these cases, obviously. That's a constant change, just like the constant change in the table of values. This is a constant increase in cost all the way along that line. So it doesn't matter where we draw the triangle, we're able to find that it is a constant rate of change. And that's one of the big things that will tell us that it is linear. That it's a linear relation, constant rate of change. So if we have a constant rate of change, these first differences are constant. So a constant rate of change indicates that these differences are constant. And when you have these constant differences, we automatically know, well, we will start thinking about this. We automatically know that when we have constant differences in the table of value, and we've got a constant rate of change in our graph, all of these things mean that the graph is linear, and it's a linear relation. Okay, so this tells us it's a linear relation. And one other thing I'm just going to add in here is that these triangles that we've been talking about, when I mentioned up here, when I drew this one, this is the rate of change of cost, of total cost. And this was also, this other triangle down below here, this was also the rate of change of total cost. So these triangles I drew actually can be called rate triangles. I was going to draw a triangle there. These are called rate triangles. Now they are right triangles because they're right angle. The legs are parallel to the 2 axes. And these are called rate triangles because they will help us determine the rate of change of the dependent variable compared to the independent variable. And in this case, it's rate of change of total cost for each per guest. And that hypotenuse that I mentioned, this hypotenuse is actually the inclination of the line. And that inclination of the line is known as slope. Okay, so we can look at the slope of the line. We can talk about the slope of the line being how it's inclined, how it rises to the right. And slope, we can say that this rate of change of cost, so this is the contextual meaning, the rate of change of total cost is the change of cost over the number of people. That can be generalized into slope of the line that would graph this relationship. And the slope, if we know it's delta C over delta N. Delta C is this vertical leg here, and the delta N is this horizontal leg. Notice that the graph itself is rising to the right. And so this delta C can be considered the rise, how much the relation rises as we increase in the independent variable. And so we call that the run. It makes it a little bit easier to understand or to remember. So then we see that how the line increases from left to right, we can generalize in saying the slope is rise over run. What's the delta of the dependent variable in relation to the delta of the independent variable? And in this case, it's the delta cost over the delta number of people. Okay, so this slope equals rise over run, that's going to be one of our go-tos when we discuss the rate triangle. Okay, and so that's where I'm going to leave off for now. We're going to then move on to part 4 of this, just to kind of make a connection into the more general realm of plotting points and graphing on a grid. Okay, so thank you for watching here, and we'll see you in the next video.